Hello everyone, welcome to yourfaculty.com. We are going to deal with boats and streams here in this video. This is our website yourfaculty.com and this is our Facebook page. Let's try to understand the basics of boats and streams. Uh, I'll just put a small diagram to help you understand. Let's assume that there is a stream. Okay, there's water flowing and there's a boat. Now, the speed of the stream will push the boat downwards. And for you to move upwards, you have to put a force which is equal to the speed, right, to move forward. So let's take this example as upstream, right? Upstream, where you are trying to move upwards. In the case of upstream, you see that you are putting a force, which is a speed, and the stream is also pushing you down with a certain speed. So because of which, the effective speed is basically speed of the boat minus speed of the stream, isn't it? Because you are moving upwards and let's say you travel at the speed, you generally travel at the speed of 10 km per hour. That's the speed of the boat. Okay, and the speed of the stream is 5 km per hour. If that is the case, what happens is the effective speed of the boat in upstream will become 10 minus 5 is equal to 5 km per hour. Now look at the other scenario. The same boat is trying to come downwards and we call it downstream. So in that case, what happens? You put a speed of 10 km, right? And the stream also pushes you downwards. So your effective speed becomes 10 plus 5, which is 15 km per hour. I hope you are able to understand this, because when you are coming down, the stream is also pushing you down and your boat is also coming at a certain speed. So both the speeds gets added together and becomes 15 km. So please remember this, because this is what you will be applying in all your problems. Apart from this, there are certain shortcuts that you need to know so that it's easy for you to answer questions. One such as, if your speed in downstream is equal to a kilometer per hour and speed in upstream is b kilometer per hour, then your speed in still water will be half into a plus b. You can always derive it from the formula, so don't even be bothered much about this. But just in case you need to quickly solve it, remember this. A boat running downstream covers a distance of 6 km per hour in 2 hours, while for covering the same distance upstream, it takes 4 hours. What is the speed of the boat in still water? So it's a fairly simple question. What are they asking for? We know that the distance is 16 km because it's covering the same distance upstream and downstream, and the time is different when it is downstream. So let's start with downstream. So I'll put it as SD, speed of the boat in downstream, which is basically what? Your total distance, which is 16 km by 2 total time. So it's 8 km per hour. Next is upstream. How do you find that out? Well, covering the same distance upstream, they are saying it is 16 by 4, which is equal to 4 km per hour. So you have 8 km per hour and then 4 km per hour. Now they are asking for what is the speed of the boat. We know the formula. Speed of the boat in still water is equal to half into speed of the boat in upstream plus speed of the boat in downstream, which is equal to 12 by 2 is 6 km per hour. We'll spend some time to analyze this all the whole variables that we have and arrive at all these formulas that we are anyway using in this chapter. Okay, so to use that, before we start solving, I'll put some variables in place so that it's easy for us to do the calculations. Speed of the boat in downstream is equal to SD. Speed of the boat in upstream is equal to SU. Next, speed of the boat in still water is equal to S. What do you put as? Yes. And speed of the stream is equal to, I'll put as A and this one as B. That keeps it simple for us. So speed of stream is B and speed of the boat in still water is A. Speed of the boat in upstream is SU and speed of the boat in downstream is SD. So what is SD? Speed of the boat in downstream is equal to, when you're going down, you have the speed of the boat and the stream supporting you to move fast. So SD is equal to A plus B. Let's consider this as one equation. And SU is equal to, what is that? A minus B. So when you're going up, you need to put extra pressure to move up, and your relative speed comes down drastically because the stream is going in the opposite direction. So it becomes A minus B. Right? Now, if we have to do a subtraction in this equation, so what happens? SD minus SU is equal to, you cancel this out and you get 2B. So B is equal to SD minus SU by 2. What is this? This basically means speed of the stream is equal to half speed of the stream, speed of the boat in downstream minus speed of the boat in upstream. So please remember this formula can also be derived. So don't think that there's too much stress on you to remember the formula. If you just spend 2 minutes of your time, you will be able to derive this formula, or you can calculate from the question itself. Okay, so we are able to arrive at speed of the stream with variables like speed of the boat in upstream and speed of the boat in downstream. With these two values, we will be able to arrive at speed of the stream. Now, with the same equation, I'll just write the equation again: A plus B and SU is equal to A minus B. What if we add both of them? SD plus SU is equal to, you can cancel this off, becomes 2A. So A is equal to half of SD plus SU. What is this? It means speed of the boat in still water is equal to half SD plus SU, which is half into speed of the boat in downstream plus speed of the boat in upstream. Please remember, these are two very good equations formulas that you can remember if possible, else you can derive it in the way that you have done here. So let's try to solve our next question. A man takes twice as long to row a distance against the stream as to row the same distance in favor of the stream. So against the stream is what? Against the stream is your upstream. And in favor of the stream is what? You are moving along the stream. So it is downstream. The ratio of the speed of the boat in still water and the stream is, so we derive the formulas just some time back. So what do we do? Let the speed in downstream be. What are they saying? A man takes twice as long to row a distance against the stream as to row the same distance in favor of the stream. So if upstream is x, then downstream will be 2x, right? So all that we have to do now is apply our formula that we used earlier. So the ratio, right? What are they asking for? Speed of the boat in still water. What is speed of the boat in still water? Is equal to half into speed in downstream plus speed in upstream. Then speed of stream is equal to half into 2x minus x. So we just need to take the ratios of both of these by half into 2x minus x. So what are we left with? We are left with 3x by, we'll cancel this out, 3x by x, which is equal to 3:1. And that's the answer for you. A boat running upstream takes 8 hours 48 minutes to cover a certain distance, while it takes 4 hours to cover the same distance running downstream. What is the ratio between speed of the boat and speed of the water current respectively? So what are they given here? They are told that the boat is running upstream and takes this much time, and to cover certain while it takes 4 hours to cover the same distance running downstream. So here they are given the time, right? And do we have speed with us? For us to solve this, we need speed in downstream and speed in upstream, right? So to arrive at that, what do we do? Well, let's assume that the speed in upstream is uh, x and speed in downstream is y. Okay. So what is the distance covered in both the cases, upstream and downstream? They are equal. So distance covered upstream is equal to distance covered downstream. So using this uh, formula, what we can do now is we can equate both the values. So what is the distance upstream? How do you arrive at the formula? Distance is equal to speed into time. So we know that the upstream speed is x and the time taken is 8 hours 48 minutes. So 48 by 60 is equal to y is the speed in downstream into 4 hours. So 48 by 60 is what? 4 by 5. So 5 was a 40, 44 by 5. 44 by 5 x is equal to 4y. So what do we have? We have y is equal to 11x by 5. So let's use this value and now do the required substitution. Speed of the boat. What is speed of the boat? By speed of stream. What is the formula? Half into y plus x. What is y? 11x by 5 plus x by half into 11x by 5 minus x. Right? We can cancel this off. So what are we left with? 11 plus 5 is 16x by 6x, which is equal to, we can cancel this, 8, 3. So 8:3 is your ratio, required ratio of speed of the boat and speed of the water current, which is the speed of the stream. So remember our formula, which is basically half into speed of the boat in upstream plus speed of the boat in downstream. And similarly, speed of the stream is equal to half into speed of the boat downstream minus speed of the boat upstream. So we're just applying that. And how did we arrive at the speed of the boats? I mean, how did we bring it into a single variable? We didn't have the question did not give us a ratio. So please don't come to a conclusion that the answer cannot be determined. It can be covered provided we try to equate the distances with the given values that we have. So what do we do? We know that the distance is anyway same because the boat is covering the same distance upstream and downstream. So we are given a time for both upstream and downstream. We know that distances are equal. So what we did, we equated both the distances. So x into the time plus equal to y into the time, which is upstream and downstream. And we finally got a variable y is equal to 11x by 5. So using this value, we then substituted it in the ratio speed of the boat by speed of the stream, and we finally got the answer as 8:3. A man can row at 5 km per hour in still water. If the speed of the current is 1 km per hour, it takes 1 hour to row to a place and come back. How far is this place? So his speed in still water is 5 km per hour. So what is the speed in downstream? Or SD is equal to 5 plus 1 is equal to 6 km per hour. Right? And speed in upstream, SD is equal to 5 minus 1 is equal to 4 km per hour. So we need to now find out the distance, right? So we don't know the distance. That's what we need to find out. And what have they said? They said that the total time to go and come back is equal to 1 hour. So we know the time is 1 hour. And what is time? Time is equal to, so speed is equal to distance by time. So time is equal to distance by speed. So here, one part of the distance is what? One part of the distance is upstream. So upstream distance can be written as, if you mark it as x by 4 plus then the downstream distance as x by 6, right? Why did I write this? The total time taken to go upstream and then downstream. So this is what you have. So if you now try to equate the equations, you'll get 2x plus 3x. This is equal to 1, right? Because 1 hour equal to 12, and hence x is equal to 2.4 kilometer. Try to solve this equation and you'll get the answer. Thanks for watching our video. You can subscribe to more videos at Your Faculty channel. Like us on our Facebook page and our LinkedIn page, and you can also follow us on Twitter. Thank you.